Hi, Chelsy. How are you doing?
Hi, sir. I'm good. How are you?
Good, good. So today, what do you want to do?
Today, I wanted to go over some practice questions from chapter 6. So it's a practice quiz from school.
Okay, so you can share that with me, and then we can work on that.
Okay. Okay.
Perfect. Okay, so small print. Can you read the first question? We'll look into a solution.
Yeah. So the first question is state the domain, range, and x-intercepts of y equals 10x.
Correct. So can you answer this question?
So would the domain and range be, for domain, would it be XCR?
Yeah, so sketch a graph so that you get fairly good idea about how the function will look like. Tan x is kind of like this, right? It is a period of pi, correct? So one cycle I'm sketching for you. This cycle repeats, right? So it has these vertical asymptotes and therefore it has restrictions, correct? You know, tan x can also be written as sine x over cos x. And therefore cos x is 0 will give you the restrictions, perfect? So here it is like minus pi by 2 and pi by 2. That will give you cosine as 0. So think like this. Tan x is sine x over cos x. And of course, cos x should not be equal to 0. Now, cos x is 0 for odd multiples of pi by 2, correct? So these multiples are the restrictions, which are the vertical asymptotes. So we have x is not equal to odd multiples of pi by 2. I can write this as pi by 2 times 2n plus 1. 2n plus 1 will make it odd multiples, right? Where n belongs to integers. So we have taken care of both plus and minus. Correct?
Could you explain the 2n plus 1 one more time?
Okay, so see, it is 0 at 0, correct? But it is a vertical asymptote at pi by 2. So if n is 1, then 2 times 1 is 2 and plus 1 is 3. So 3 is an odd number, 3 pi by 2, correct? Similarly, you get 5 pi by 2, 7 pi by 2. So these are the odd multiples of pi by 2, where we are going to have a vertical asymptote, right? So those are the restrictions. If we have even multiples, then we'll get zeros, right? So that's the whole idea. So it has to be odd multiples of pi by 2. So now we can write down the answer for the first question, which is, it says state domain. So we can write domain as domain of this function will be x belongs to real numbers, so that x is not equal to, I should write, okay, odd multiples of pi by 2. Odd numbers we get by 2n is even, correct? If I add 1 to this, it becomes an odd number. So odd multiples of pi by 2. Set will always be in curly brackets. So that becomes the domain. As far as range is concerned, there is no restriction on tan function, and so y belongs to real numbers is the range. The x-intercepts. X-intercepts are the points where sine is 0, right? Sine 0 will give you x-intercepts. So we can say the x-intercepts are at n pi. All the multiples of pi, where n belongs to integers. So here also I should write n belongs to integers. That is plus minus 1, plus minus 2, plus minus 3. So that gives you a general solution, general answer for this particular question. Is it okay?
Okay.
So I hope this concept is absolutely clear. So let's move on and take up the next question now. What is the next question?
Number 2 is find the angular velocity of a wheel of radius 13 centimeters if it rotates at 90 revolutions per minute as an exact value.
Perfect. So we are given the radius. Radius is 13 centimeters.
Mhm.
Now you have to find angular velocity. So we normally write angular velocity with omega, and it is measured in radians per second, right?
Yeah.
You are given that this wheel rotates at 90 RPM. That means 90 revolutions per minute. You get the idea.
Mhm.
So that is also in a way angular velocity. However, it is in revolutions per minute. So you have to convert the units to radians per second. So how will you do it? You can say 1 minute is 30 seconds, right? So 60 seconds. So 1 minute over 60 seconds. So you get this seconds. As far as the revolution is concerned, one revolution is 2 pi radians.
Mhm.
I have written revolution in denominator since I want to cancel them out, right? I will
Yeah.
cancel revolutions with revolutions, minutes with minutes. And what do I get? I get 90 times 2 pi. The units are radians per second. Do you see that? So I got my exact value. 90 times 2 is 180 pi radians per second. So that becomes the value of angular velocity. That is the exact value. You see in this formula, we have really not used the radius, correct?
So do we not need to use the 60 in the calculation?
What 60?
Because it's 60 seconds, right?
Yeah, we use 60 seconds. 1 minute is 60 seconds. So we converted minutes to seconds. Do you see that?
Mm-hmm.
We canceled minute, and we got 60. Oh, yeah. In the denominator, there was 60. You're right. I forgot.
Yeah.
Oh, my God.
That's what I was
Yeah.
trying.
Good job. So we get 3 pi radians per second. Yes. Yeah.
Yeah.
I
Okay.
forgot. I didn't see that. Yes. Perfect. So 3 pi radians per second. Thank you, Chelsea, for that. Yes. Perfect. But the idea is that radius is not used, correct? How do we use the radius? Well, if we were supposed to find some distance traveled by a point on this periphery, then we would use it, correct? For example, if they say there is a nail which went into 3 and then it rotated, right? How much distance did the nail rotate in 5 seconds? Something like this.
Mm-hmm.
Then we might use, we will use that 13 centimeters, which you could convert into meters. Is it okay? And then use. But in this case, it is not required. Perfect?
Okay. So this is all you would need to do to find angular
Simple as
velocity.
that. Simple as that. Just convert from revolutions per minute to radians per second. You get your angular velocity. Nothing else.
Okay. So you don't need to do, because there's the formula theta over time. You don't
A
need to
equals to R theta?
Yeah.
Not required.
Not required? Okay.
Yeah. Question number 3. Find the exact value of cos 11 pi by 6, right? So now you have to find cos of 11 pi by 6. How will you find?
You can actually draw it on the
Okay, perfect. So you are dividing this pi into 6 equal pieces. 11 pi by 6 will be right there, and this is 11 pi by 6. Because the total is 12 pi by 6, correct? That is 2 pi, correct? And this is 11 pi by 6. You are in quadrant 4. So if you apply the cos rule, we know we have a positive value. So this is positive, correct? Now, since it is acute angle here is pi by 6, so we could write this as it is equals to cos of pi by 6. Is that clear to you?
Yes.
And to find the exact value, you can actually sketch the triangle. You know the exact value can be found from 30, 60, 90 or pi by 6, pi by 3 triangle, correct?
Yeah.
Sides being 1, 2 and square root 3. And therefore, for this, we get the value which will be equal to square root 3 over 2. So that becomes our answer, square root 3 over 2, correct?
Mhm.
Is this clear to you?
Yes.
Perfect. Let's move on and take the next question. Question number 4. Can you please read the question?
Find the angle to the nearest hundredth of a radian for x is greater than equal to 0 and less than and equal to 2 pi, where sine x equals negative 0.7623.
So you have to use the calculator in radian mode, right? So
Yeah.
just change that to calculator in radian mode. That is very important. And now we need to find the angle. Since we are given sine as negative, it means what? We have two solutions and the quadrants are?
Where sine would be negative.
Yes.
Yeah, so quadrants 3 and 4.
Correct. So to find the value, you will actually find the related acute angle. Perfect. So what is the related acute angle? Let's say, let's call this as alpha. So we'll say, well, sine alpha is equal to 0.7626. So alpha is sine inverse of 7626. Can you tell me how much you get?
0.86.
Radians. So radian is the default unit. Yeah, it is a ratio as you understand. And so writing radians or not writing radian doesn't make difference. It is understood to be radian, right? But it's good to write. So we have this angle as equals to 0.86 radians. Now, find the exact value to the nearest 100th, you round it, right? Now, let's write down our answers. The answers will be what? One of them will be pi plus 0.86. The other one will be
2 pi
minus, right? So our answers will be, we have two answers for this. X is equals to pi plus 0.86. Can you please calculate and tell me? And the other one is, so better, when you did inverse, write 3 decimal places because you're going to add pi to this. So can you tell me 3 decimal places? What is this angle?
Yes. So 0.867.
So 867. Okay, so I'm writing 867. Is it okay?
Yeah.
And then you do 2 pi minus 0.867 and write down the value.
Okay.
So those are the two answers for you.
Do you want me to calculate them, sir?
Yeah, you can calculate right down. That would be your right answer, correct? No harm.
So for plus 0.867, it's 4.01.
Okay.
Yeah, I rounded it. And then 2 pi minus 5.42.
Very good. So radians.
Yeah.
Perfect. So we get this answer. Is it clear to you, right?
Yeah.
Perfect. Can you take up more questions? Do you have more?
Yes. There's a few more.
So can you please read question number 1?
Yeah. Number 1, for f of x equals negative 5 sine 3x minus pi over 3 plus 4. Part A is find the instantaneous rate of change when x equals pi over 6.
Okay. So basically you have to find instantaneous rate of change at x equals to pi by 6. So what I would like you to do is find a point which is very, very close to x equals to this, right? So find the value f of pi by 6, what do you get? Sine of 3 x minus pi by 3 plus 4, correct? You need to find instantaneous rate of change at, so instantaneous rate of change at x equals to pi by 6. So find the value of this function at pi by 6. So let me write this as f of pi by 6. Also find the value of the function at pi by 6 plus 0.01. And then instantaneous rate of change will be f of pi by 6 plus 0.01 minus f of pi by 6 divided by 0.01. So that is what you'll get as your solution. Is it okay?
Okay.
So you have to plug in all these values in your calculator to find this particular answer. Is that clear?
Mhm.
So try to do with graphing calculate with your calculator, change the mode to radians. So that is important. So mode to radians. And then you calculate and get your answer. Is that clear?
Okay.
You can do that later. Now, what is part B? State the period, axis, amplitude, and phase shift. So let's do this. So the period is time period t. So first time period t will be 2 pi by 3, correct? Since the k value is 3, correct?
Yes.
Axis. As far as axis is concerned, it is plus 4. So axis is y equals to 4.
Mhm.
Amplitude is 5. A is 5.
Mhm.
Phase shift is pi by 3 to the right. So that is how you can answer part B.
So for when they ask for amplitude,
Yeah,
you say the absolute value, right?
absolute value. Yes. That minus signifies that instead of going up, it is going down from that axis. So that is part C, 5 marks. Sketch the function. Parent function is not required. Being sure to show 5 significant points per period. Sketch at least one period. Is it okay? So let's
Mhm.
try to sketch it. I'll erase all this and we'll see how do we sketch this particular function. Now, a couple of ways. One is you could take special points, which you know of sine function. And these 5 points normally are 0, 0. And then we have pi by 2, 1. Pi 0, correct? 3 pi by 2 minus 1. And 2 pi 0. So that is sine waves. This is parent function sine x. And on this, you can do the transformation, and that is the x values are multiplied by 1 over 3. And then to these x values, you add pi by 3. As far as the y value is concerned, you multiply by minus 5, and then you add 4. So you get your new coordinate points, and then you can sketch. That is the way you could do it. But what I prefer to do is something like this. We know that the axis is 5. So what I will do here is I will do it at 2-step. So I'm going to show you my method, which is called 2-step sketching. Very important. I will not do any calculations of these points. So we'll just, let's say this is we'll try to make one wave without phase shift. So first wave which I'm trying to make is without phase shift. And let's say this is my scale. We know that the time period is how much? We just calculated. Time period was 2 pi by 3, correct?
Yeah.
So this point here is 2 pi by 3. That is one full cycle. Now within this cycle, I will have 4 equal parts. So it goes through 4 quadrants. That is the whole idea, right? So I'm just drawing these dotted lines to show you those 4 equal parts. Is it okay?
Mhm.
So the middle value will be 2 pi by 6 if I divide by, right? Half of that will be 2 pi by 12. Perfect. Now 2 pi by 12, and this is 3 pi by 12. We have to add 2 pi by 12 each time. So 2 pi by 12, 4 pi by 12 will give me this, and this is 6 pi by 12. So I'm writing 6 pi by 12, not in the simplest form, but like this. You get the idea,
Yes.
right? Of course, you can simplify these numbers and write them as pi by 6 and 2 pi by 3, pi by 3. You can do all that.
Mhm.
But it's better to write in this fashion so that you understand how we get our scale. Is it okay?
Yeah, so, sir, what you did was you divided the time period by 4 equal parts.
Yes, yes.
So 2 pi over 3, you divided by 4, you got 2 pi over 12.
Yes.
And so for each section, you added 2 pi over 12.
Correct. For each section, I added 2 pi by 12. So I get 4 pi by 12, 6 pi by 12, and the last one is 8 pi by 12, right? So 8 pi by 12 reduces to 2 pi by 3. You get the idea?
Yeah.
8 pi by 12. So that is how I've done. Okay. Now, as far as the axis is concerned, it is 4, and the amplitude is minus 5. So, I mean 5. So let us say this is 4 for us, axis.
Mhm.
So this is at 4. In that case, we are going 5 up and 5 below. So I'll actually reconstruct this because those numbers are on my way. So okay. So I'll reconstruct this, okay? The slightly bigger space I'm going to take now. You got the idea,
Yeah.
right? So, okay. So here we go. So we have the axis at y equals to 4, right? And maximum value is 5 above and 5 below. So let's say this is 5 above and 5 below will bring it to minus 1. Is it okay?
Mhm.
So, and we'll divide this into 4 equal parts. The wave starts, since it is negative, do you see it is negative? So wave will actually move down. So 1, 2, 3, 4, and 1, 5. Do you see those 5 points? Correct? So this is my first wave, which is basically minus 5 sine of 3x plus 4. I have not included the phase shift. I have to go pi by 3 to the right. Is it okay?
Mhm.
Now see, the scale is, let's write down the numbers on the scale. The time period is 2 pi by 3. So at this point here, we have 2 pi by 3. Half of this is, because 2 pi divided by half of this is pi by 3. Is it okay?
Yeah.
And half of that is pi by 6, correct? Correct? So if you add 1 pi by 6, 2 pi by 6, 3 pi by 6. So 3 pi by 6 will mean pi by 2, correct? So that becomes your scale. Now, and this is 4 for you. This is 9, and that is minus 1. You have to now move your graph pi by 3 units to the right, correct? So let's move everything to pi by 3. Pi by 3, you know, is 2 divisions, right? So this point goes to this point. Do you see that? Pi by 3. So that much is pi by 3 for me, correct? So basically, the wave starts from here instead of there, right? So So we have added pi by 3 on the right hand side. And my wave now is going from here. That's my second point, third point, fourth point, coming back. So that is my final wave.
Okay, yeah.
So we shifted pi by 3 to the right. So this becomes my final equation, which is minus 5 sine 3 x minus pi by 3 plus 4. So that is what I call as two-step method. I did not really do any calculations for points, correct? So we have drawn the axis, got the amplitudes and the time period. Time period was calculated as 2 pi by 3, the k value, correct? Amplitude was 5, which we calculated earlier. Axis was at y equals to 4, and that gave us all the related points for the graph, correct? Perfect. That's how you are going to do. Let's take the next question. So can you please read the question?
Yeah. Number 2, a mass suspended from a spring is pulled down a distance of 2 feet from its rest position. The mass is released at time t equals 0 and allowed to oscillate. Question A, or part A. If the mass returns to the position after 1 second, find an equation that models its motion.
Correct. So when you pull that particular mass and then release, so it goes to, it'll go up and then it'll go actually on the other side also. It will oscillate about this particular point, correct? So it says a mass is suspended by the spring and is pulled down a distance of 2 feet from its rest position. So this is the rest position. So it is going up and down from here, right? If the mass returns to the position after 1 second, so if it goes up in t equals to 1, so right, find the equation of the motion, model its motion. And part B is find at what 2 times within 1 cycle is the spring at 1.5 feet above the rest position, right? So basically, in this particular situation, this is one end, right? And the other end, it'll go same distance up because it has been pulled that much. So that much force, it will go up, correct? So 1 second it takes to go to the initial positions. So if the mass returns to this position after 1 second, find the equation. So time will be how much? So from here, 1 second, 1 second, 1 second, and 1 second. So 4 seconds is the time cycle. Is it okay? Do you see that? So I could model this as a cosine function. So my wave is, let me use another ink to show the wave. It is here at present when it is released, and the wave will go up and come down. Do you see how?
Yes. So how did you know it was 4 times?
Because from here to the normal, it is 1 second. Then up also 1 second, come 1 second and 1 second.
Okay. So the starting point is the
Bottommost.
Minimum, the bottom, yeah. Okay.
Yeah, so maximum stretch. That is what it is. And you want to find, it says what? The mass suspended and just 2 feet below. So if I take this as my axis, right? This is
so that's the amplitude.
This is -2 and this is +2. Is it okay now?
Yeah.
You want to find the times when it is 1.5 above the rest position. So second part, we have to calculate this particular point when it is 1.5 above these 2 points time. Is that okay? So we first find the equation, sine function, or we can use it cosine minus. That'll be good. So we'll write that height with time as equal to minus amplitude being 2 units, cos of time period. So time period is 4 for us. So the k value is 2 pi by 4, correct? Which is pi by 2, correct? pi by 2 plus t, and we are assuming that x is to be at 0. So there is no plus minus here, correct? That becomes my equation. Is that clear to you? Since it starts from the bottom. So that is how I'm going to model. So time period is 4, k value is pi by 2, amplitude A is 2. Now to find the position t when it is 1.5 above, that means I'll write this as 1.5 equals to minus 2 cos of pi by 2t. Is it okay? So I'll divide this, so I get minus 1.5 over 2 equals to cos of pi by 2t, correct? The cos will be, you can find the related acute angle to, you're looking at negative values, that means you are in quadrant 3 and 4, correct? So first find cos inverse of 1.5 divided by 2. Half of this is 0.75, right? How much you get? We call this angle as alpha, the related acute angle. Yeah. Shift cos inverse of 1.5 divided by 2. How much you get?
Yeah, I got the same answer. 0.7227.
Perfect. So that is your related acute angle, but the answers will be, I mean, we'll still find, this is pi by 2t. Remember that, okay? So the actual values which we are going to put is pi minus and pi plus alpha, right? So the value of x or t should be, I should say pi by 2t, right? Because this is my argument. Is it okay? Pi by 2t, that is the argument, is equals to pi plus 0.7227 and also pi minus 0.7227. So t will be, multiply this by 2 by pi. So if I add pi, I get, let me redo here. So we get pi by 2t is equal to 3.864 and t will be equal to 3.864 times 2 by pi. So I'll multiply this by 2, divide by pi. And I get 2.46. As one answer, 2.46 seconds. The other answer will be, I'll do pi minus 0.7227 times 2. Wait. First, it's good to write that answer. I'll do shift pi minus 0.7227. So the other answer is pi by 2t is equals to 2.4188. So t is equals to 2.4188 times 2 over pi times 2 divided by pi, 1.53. 1.5. So those are the two times, 1.54 and 2.46.
So you added it and also subtracted it. You did
Correct,
it.
correct. So when I added, I got that time as 3.864. And when I subtracted, I get 2.4188. Is it okay? Then this is pi by 2t, right? That's the angle theta, right?
Mhm.
So to get the value of time t, I multiplied it by 2 by pi by, right? So it did the calculation here for both and got the answers as t equals to, let me write that. So we get t is equal to 1.54 seconds and 2.46. Makes sense. So those are the 2 points.
And you did that because we had two different angles, right?
So you find the related acute angle first, then you find the theta, right?
Mhm.
And actually the theta is equals to pi by 2t. So solve for t.
Okay.
Principal angle theta, correct? You can say theta 1 and theta 2. And then you solve for t because that angle theta is equals to pi by 2 times t, correct?
Mhm.
So
And sorry,
yeah,
sir, could you one more time explain how you got pi by 2?
how I got pi by 2. Sure. So the first thing is we found that the time period is 4 because from the point it is released at t equals to 0, it goes back to the initial position in 1 second.
Mhm.
So that is 1/4 of a cycle. Do you see
Mhm.
that? So it is only this much distance, 1/4. Then it will go up, down, down. You see that? So 1, 1, 1, 1 will make it 4 seconds.
Okay.
So if t is equal to, so if I write t equals to 4 seconds, then k will be 2 pi by 4, correct?
Mhm.
So we get pi by 2.
Okay.
Correct. Since we started with negative cos, there is no phase shift because we have taken the minimum, right? So starting point at t equals to 0. And so there is no phase shift. Amplitude being 2, starting from lowest point, so -2. That's how we get our equation.
Okay. Yeah.
Yes?
Mhm.
Great. So with that, we complete this. Do you have any more questions?
No. The practice problems are done here.
Yes. So now I will suggest you can look into my YouTube channel. Just type in uh, Radian measurements applications playlist, and you'll get many there. So we can now take a few questions from my YouTube channel. Okay. So stop sharing. Go to YouTube. Just type Anil Kumar Radian applications, Radian measurement applications playlist. And then see what you get. I'll tell you which playlist to do. So we normally see Ferris wheel or a bicycle wheel. It just picks up a nail or a paint or some spot, correct? And we have to find what is the angular velocity, how much distance is traveled, all those type of questions. Or a car wheel, those type of questions is what we are looking for.
Yeah.
Correct. So we have many examples. Go down. Let's see a playlist. Okay. So So we also 23 videos. Click this. The very first one is the test question itself. So I just shared with you a test paper of student, and those are the type of questions. Normally, the first question is set of 10 multiple choice questions. Correct. So those are the type of questions you will be seeing. So it's a good idea to go through this question paper. This is a past question paper. Is that clear to you?
Yeah.
So watch this video, go to this, and then look into many other videos are here. The next one is transformations. Okay, we'll skip this. Modeling with trigonometric functions, 41, tidal waves. But that may or may not be, it's a 41-minute video where I'm discussing many applications. So that's very good test paper actually. Okay.
Mhm.
Ferris wheel. See, the last question is, you can scroll down. So this video is with my student Amy. She was sharing many questions. So we have about 45 minutes video there. Okay, so speed of the car. Do you see those last Ferris wheel? Speed of the car, right?
Yeah.
And above that is average rate of change. Similar to what you did, instantaneous rate of change. So this playlist will be actually very good for you. We have spring also, 16:37 minutes, model spring. Do you see that? Click that.
Yeah.
So these are very common questions. Well, this question is easier since we have already given you the equation. You get the idea. So it's been pulled towards the flow, but you will understand why the time period was that much or things like this. Sketch a rough graph of height versus time. Find the time t when the height is 18 centimeters. So you have to do the calculation just as we did, correct?
Do you have, sir, angular velocity questions?
Or just type angular velocity, Anil Kumar, angular velocity.
Okay.
Yeah, click. So many videos. This one is the latest, the second one. Yeah, click this. So let's go through this video. I just uploaded it recently, just 7 hours ago, right? So look here. So very interesting, simple questions. The very first one is, the hard disk in a personal computer rotates 7,200 RPM. Find its angular velocity. This was also your first question, kind of.
Yeah, very
And
similar.
the way to do it is, now you understand, revolutions per minute. 1 revolution means 2 pi radians, correct? And 1 minute means 60 seconds. Convert the units, get your answer. Okay? The next one, find the angular velocity of seconds hand in a clock. You know, the clock moves, right? So what is the angular velocity of the seconds hand? Can you tell me? Revolutions per second. In 1 second, how much revolution does it go through, right? So actually seconds, when will it move full circle? In 1 minute, it goes 1 full circle, right?
Yeah.
So from there, you can find its angular velocity is 1/60th. So 1 division, 1/60th, correct?
Okay.
You can move further, go to the middle of this particular video. Yeah, go further, right? So we'll discuss, I'll discuss with you, I'll discuss all the answers. Here's a nice one. Can you please read this question?
A cycle with tires 70 centimeters, traveling at constant speed of 15 kilometers per hour, runs over a fresh paint strip. It has a fresh paint spot on the tire. What is its velocity in meters per second?
How will you do it? Tell
me. So first we have to convert, right?
Correct. So 15,000, 15 kilometers in meters will be 15,000, right? Meters. Time in hours, 3,600 seconds, correct? So we got meters per second, right?
Yeah.
Now, so that is velocity. You want to find angular velocity, V equals to omega r. So the angular velocity is this velocity divided by the radius. So once you calculate that, divide by radius, which is 35 centimeters or 0.35 meters, right? Everything. So this will be, you have this velocity 15. I'm not simplifying it, just writing the whole numbers, over 3,600 divided by 0.35. Do you see that? You get the value of omega. Got the idea? Nothing more than that.
Okay.
And part C is, can you please read this question?
Here, let me move it. Number 5.
Yeah.
Model the vertical height of the paint as a function of meters a second. Assume that the paint spot is at the bottom of the tire initially.
So just as you did earlier, it is starting from the bottom. So it's a cosine negative wave, right? Yeah. And the equation will be y equals to minus, because starts from the end, right? Bottom. And the radius is 0.35 cos of omega t. Omega is known to you, right? Omega t, right? And plus the axis is 0.35 above, 0.35. Do you see how easy it is to answer? Yeah. So you can go further down and see the answer.
So, sir, with the radius then, if you were given the radius, it's usually the amplitude?
Yes, yes.
Okay.
So for example, yeah, you can go. Yeah. So you can go further down, almost at the end. Yeah. So do you see I just converted the units to get omega? You see that? Very simple. And next, yeah, let's see the solution of the next question here. Okay, so again, you see what is the velocity in meters per second? Just convert the units. You do not have to apply any r, theta, and all those formulas. Just convert the units. Is that okay?
Mhm.
And then go further, you'll see the solution of 4 also. Omega is v over r. You got the velocity, which is the linear velocity, divided by the radius, you get the angular velocity. Simple.
Mhm.
And then part C, go further down and see the equation. How simple it is without, yeah, stop. So do you see minus, because the cosine wave starts from the bottom as I have shown here, right?
Yeah.
0.35 is the radius, cos omega t. This is a formula for you to remember. You write 2 pi k and all those things. No, no. When you are given angular velocity, use that. So we calculated 11.9 radians per second as the angular velocity in fourth question. Use that 11.9 t, done, and plus 0.35. We have solved the question. You see that?
Mhm.
How easy it is. So you don't have to redo that omega is this. Oh, I've seen so many solutions which are like round and round. They come back to this only. So the beauty of angular velocity is that any application which involves rotation, you should work with angular velocity. It makes things very simple.
Mhm.
So that's a very beautiful example. I've seen that in many test papers. So I think that will help. Okay. So you can explore more and go through more of such questions that will help. So is everything clear to you?
Yes. Thank you,
Okay,
sir.
great. Thanks a lot, Chelsea, and have a good day. All the
Okay.
best to you.
Bye, sir.
Bye.